Good morning, students. Welcome to the first e-class of physics. Children, today we are firstly going to discuss about our syllabus, in which we are having two books in our physics syllabus. Very first book we are having 8 chapters, and in the second book we are having 7 chapters. So we will start from the first book, in which we are having very first chapter as the physical world. So that chapter is basically introductory chapter, and this is not included in our examination. So technically our syllabus is starting from our second chapter, that is units and measurement. Children, here I am just sharing you the marks distribution according to the chapter, and total theory we are having of the 70 marks. So physics paper we are having of the 100 marks, in which we are having 70 marks of the theory portion and 30 marks of the practical. So you can go through the marks distribution according to the chapter. So now we are going to start our first chapter, that is units or and measurement. So before going to start the chapter, firstly we will discuss about the name of the chapter and the uses of the chapter. So very first chapter is units and measurement. So very first question that comes in our mind, that is what is the need of the measurement. So you all know in our day-to-day life what is the need of the measurement. The need of the measurement basically is the medium to convey the message, to convey the things, to convey the amount of the things from one person to the other person. Just for example, if your mom asked you to go to the shop and bring some rice, so how will you convey the message to the shopkeeper? Done? So, whenever we are not getting the instant, so how will you convey the message to the shopkeeper? Similarly, in any of the condition, in many of the condition, we are when we are going to the market and we want to purchase something, in every of the condition that is not possible to count everything. So measurement, need of the measurement is starting from that point. That means measurement is the standard measurement, is the standard quantities of the things, in which the quantity is included in the standard amount. So that is, without measurement our day-to-day life is not very easy. So a standard measurement is the standard measurement tells us about the things in the standard way. So that is the need of measurement in our day-to-day life. Similarly, if we are going from one place to another place, then how will we calculate the distance? So to calculate the distance, we are having the standard measurement, and we are having some specific rules of physics to calculate the distance between one point to the other point. So this is the need of the measurement in our day-to-day life. So children, so chapter is starting. Your chapter is starting from the very first topic we are going to discuss, that is the physical quantity. Secondly, we will discuss about the units of the quantities today. So whenever we are talking about the quantity, so from class 6 we are talking about some of the physical quantities that are used in the physics to calculate the different things. That means we use distance to calculate the distance, to calculate the amount between the one point to the another point. We calculate the velocity of the object, we calculate acceleration of the object, we calculate mass of the object. So all these are the physical quantities that included some amount, some quantity of that specific thing. So very first, if we talk about the physical quantity, so how will we describe of the any of the physical quantity? So if we simply say that what is physical quantity? So physical quantity is considered as the quantity which can be measured directly or indirectly by the different methods. So how will you understand physical quantity? Any of the quantity which can be measured directly or indirectly by the different methods, those quantities included in the category of the physical quantity. Done. So what are the different direct or indirect method? If we want to measure the length of some specific strip or some specific thing, so what will we do? We will take a meter scale and directly we can calculate the length of that particular strip. But whenever we are having some of the object is very far away from us. So how will we calculate the distance or the different quantities related to that particular object? So to that particular object in that particular condition, we use different indirect methods. That means in which we are having height and distance method, we are having radar system, sonar system. So different of the indirect methods we are also having to calculate the different distances and the many more quantities. So any of the physical quantity is defined as which can be measured directly or indirectly. And if we just go through the definition, a standard definition of the physical quantity, a characteristic or property, a characteristic or property which can be measured and which follows laws of physics is called physical quantity. Now the question is that is every quantity is considered as a physical quantity? The answer is no. Every quantity we cannot consider in the category of the physical quantity. Our emotions, that means our happiness, our sadness, these quantities we cannot measure as the physical quantity. If we are very happy, then how will you tell us the amount of your happiness? That is no particular measurement to calculate our happiness. So that particular quantity happiness not follows the rules of the physics, and we are not having any standard measurement to calculate our happiness. So that particular quantity is not in the category of the physical quantity. So what type of quantity is under the category of the physical quantity? So any of the quantity which follows the laws of physics and which can be measured by indirect or direct methods. Those type of quantity are only in the category of the physical quantity. For example, we are having many more example around us of the physical quantity. Just for example, if we want to calculate the mass of the object. So we can calculate the mass of the object easily by using the different standard units or the measurement. If we want to calculate the length, so we can easily calculate the length by using different standard methods. So these all quantities are under the category of the physical quantity. Now the question is that whenever we want to express any of the physical quantity, so how will we express the physical quantity? So, whenever we mathematically represent any of the physical quantity, so to express physical quantity, we are having a standard formula, that is physical quantity equals to numerical value into the unit. Numerical value into the unit. So, what is unit? Unit is the standard measurement by which we express that particular quantity. So, whenever we are talking about if, for example, if any of the object having mass of 20 kg, if we are saying that if any of the object weighs 20 kg, so what you understand by this sentence? So, 20 is the numerical value into kg. Kg is the unit. So 20 kg completely tells about the weight of the object or the mass of the object. That means by the statement 20 kg, you can understand that 20 kg is the mass of the object. Done? So, what physical quantity we are expressing? Mass. That means at place of x we are having mass equals to n. Suppose, for example, we are having 20 kg. So, 20 is the numerical value of the quantity into kg. Kg is the unit of that particular quantity, that is, in the given example, that is mass. So, in any of the condition, any of the physical quantity is defined as the product of the numerical value and the unit. Then, after that, we will talk about what is unit. What is unit? So, as you all know that any of the quantity, any of the quantity which to define that particular quantity, a particular standard measurement is used, right, to express the same type of the quantity. Right? So that particular standard measurement is defined as the unit of that particular physical quantity. So we can express that unit of a quantity is a standard measurement of the same quantities for the comparison. Just for example, if we're having 20 kg of mass, 20 kg, and if we're having 200 grams, so both grams and kg, both are the units of the mass. But by the gram and kg, we can compare the amount of that particular quantity. Done? So unit of any of the physical quantity is the standard measurement of the same quantity. We are comparing the mass of the object in the both of the condition 20 kg or the 200 grams. So same quantity for the comparison. Now we can understand if N1 is the numerical value of the physical quantity for a unit U1 and N2 for the unit U2. Then N1 U1 equals to N2 U2. Then, for example, we can say that 1 kg equals to the 1000 grams. So 1 into kg. So 1 is the N1 and kg is the U1 equals to the 1000 grams. 1000 is the N2 and grams is the U2. So all the time 1 kg will be equals to the 1000 grams. That defines that particular statement, that is N1U1 equals to N2U2. So we can say that N, the product of the N into U, is always a constant. So children, I hope you understand the concept of the physical quantity and the units. Now, physical quantities are of the different types. We are having many more physical quantities. Now, we have to classify the physical quantities in the different categories because we are having two different types of the physical quantities. So, some of the physical quantities are the fundamental physical quantities and some of the other type of the physical quantities. Right? So, in the particular scenario, we are just going to discuss about the what types of the physical quantity and what types of the units we are having here. So, in the class 11 or simply we classify any of the physical quantities into the two categories. Very first, fundamental physical quantities and their units, and second one is the derived physical quantities and their unit. So what is the difference between fundamental physical quantities and the derived physical quantities? Fundamental physical quantity, in the category of the fundamental physical quantities, only those quantities are involved which are independent from any other physical quantity. That means which can neither be derived from one another nor can be resolved in any other unit. I hope you are getting the point. What is the fundamental physical quantity and their units? Fundamental, in the category of the fundamental. In the category of the fundamental, only those quantities are considered which are independent from any other quantities, which are independent of the any other quantities. Done? And those quantities having some specific units, and those units are included in the category of the fundamental units. So we can say that fundamental units are those units which can neither be derived from one another nor be resolved into any other. Or simply we can say fundamental units are those units which are independent from any other unit. Done? In the second category, before explaining the example, we will just go through the second type of the quantities or the units, that is the derived physical quantities and their unit. So derived, in the category of the derived physical quantities and the units, we are having those quantities other than that fundamental physical quantities and their units, other than that fundamental physical quantities and units, all physical quantities are categorized into the category of the derived units and the quantities. Now we will compare the examples of the both types. Suppose, for example, if we want to calculate the mass of the object, so simply what will we do? We will take the physical balance to measure, and we can directly measure the mass of that particular object. If we want to calculate simply the length of the strip, simply a small strip. So what will we do? We simply take the meter scale and we can calculate the length of that particular strip. Then now the second example. If we want to calculate the if we want to calculate the speed of the object. So to calculate the speed of the object, what you need? We need the two quantities. One is the distance and one is the time. If we are, if any one value is absent, then we cannot calculate the speed of the object. That means the speed of the object completely depends on the two quantities, that is distance and the time. Done? But whenever in the very first part we are talking about the mass and the length, so mass and the length we can directly calculate. So mass and the length are independent from any other quantity or any other quantity. But whenever we are talking about the speed or the acceleration, we can take many more examples. So those quantities depend on the different quantities, or we can say those quantities depend on the fundamental physical quantities. So mass and length both are in the category of the fundamental physical quantity, where speed, acceleration, both quantities are independent, are not independent. They are depend on the two types of the quantities. So those quantities are in the category of the derived physical quantities. Then I hope you are understanding the concept of the fundamental and the derived. Then so whatever amount of the quantity, whatever number of the quantity we are having for the fundamental, other than that, all the quantities are in the category of the derived quantities. Done. So standardly we are having seven types of the fundamental physical quantities and their units. So units of the fundamental physical quantity is considered as the fundamental units. So we are having here mass, length, time, temperature, electric current, luminous intensity and quantity of the mass. These all seven are in the category of the fundamental physical quantities and their units are considered as the fundamental units. Other than that, the seven fundamental physical quantities and the units, all quantities and their units are in the category of the derived units. Done? So now in the notes, we are not having the definition of the quantities, fundamental physical quantities and the derived physical quantities. Directly, we are having the definitions of the fundamental units and the derived units. So, there is no need to write down the definition of the fundamental physical quantity and derived physical quantity separately. So, one more time, I am just repeating the topic. Fundamental units are those units which can be neither be derived from one another nor be resolved into any or any other unit. Resolved means splitted. Resolved means splitted. And derived units, the units which are derived from the fundamental units and can be expressed in the fundamental units in terms of the fundamental units are called the derived units. Done? So we are having seven fundamental units and other than that seven fundamental units we are having all are in the category of the derived units. So these two topics we covered today. I hope you understand the concept of the physical quantity units and the classification of the units. So that's all for today. Thank you.